Hello, hello. After the short lunch break, we're here with our next speaker, Alireza Eskandari, who will talk about security in shared networks. Nice to have you here. Please tell us a few words about yourself and let's talk about security.
Okay, thank you very much, Yvette. I'm very happy to have this opportunity to be in this meeting. I am Alireza Eskandari, and I want to present you some concerns and solution about providing security in shared networks with VMware NSX. Let me change the slide. Okay. If I want to introduce myself, I have worked as a manager of cloud services in Afranet for about 7 years. In there, we have had installed CloudStack to provide public cloud services to our customers. So from there, I have a very good experience as a user on CloudStack. After that, I worked as a DevOps engineer in Snap. Snap is a taxi sharing service in Iran. It's something like Uber. So we have many requests and workloads from different drivers and clients who want to take a taxi for the entire of the country. And after that, I am now working as a senior cloud engineer at Solviance IT Solution in Germany. It is a company that is provides some data analysis services on financial data. So we are going forward about shared networks. If you know what the shared network is, it is a type of network offering in CloudStack that shares a common L2 and L3 network to different customers. It is useful when you want to assign public IP directly to VMs. Sometimes clients has this request that we want to directly connect our VM to a public network, to internet. So you have this only solution for you is creating a shared network for them. Then they can use it, but it has many concerns because it is shared and different client and different VMs are using this shared network. Some of these security concerns are about traffic sniffing, MAC spoofing, IP spoofing, and DHCP spoofing. You know, if you don't configure your network very correctly, maybe different VMs can see each other traffic. So it is a concern. MAC spoofing occurs when some VM change its MAC address. So it can spoof its MAC address and pretend to it is another VM or doing some messy works in our network. Also about IP spoofing, the VMs can change their IP address without out of band of CloudStack management. So they can steal IP address from other VMs or using some IPs that they don't allow to use them. Also, DHCP spoofing could mess up everything in our network because you know most of the services, for example, user data services, password management services are based on DHCP. Also, traffic goes through DHCP servers through the routers. So when someone in the network tries to be a DHCP server that it shouldn't be allowed to, then your VM may lost its connection. You may can't change the VM password because the DHCP server is the server that is responsible for changing password and others. So it is important for us to address these concerns. To address this concern, we have two segments. One of them is configuration of network offering, specifically in VMware hypervisor that I have told, and using some security appliances for it. For configuration, the service offering configuration, we can configure it in a way that traffic spoofing and MAC spoofing could be resolved. If you see in the panel of in UI of CloudStack, you can see the model that we can define, or service network offering. At this section, you can, this is the important part about configuration of network offering. You can see we should reject promiscuous mode if we want to prevent clients to see each other traffic. We should select MAC address change to reject also, and force transmit to reject, and even MAC learning to reject. If we set these options in network offering to reject, then those two concern, traffic spoofing and MAC spoofing, should be resolved by some features that VMware natively provide us from its distributed virtual switch feature. But we go more further, and we want to solve the problem of DHCP spoofing and IP spoofing. For this reason, we can use VMware NSX as a solution. So we can prevent DHCP spoofing by using its firewall feature, and prevent IP spoofing by using a spoof guard solution. I want to tell you something about the configuration of NSX here. You know, NSX is a solution for VMware that can provide us a SDN, software-defined network. So we can have different VXLAN, we can have some routers there, we can have load balancers, we can have firewalls, and different network service can be provided by this solution. But as of this, CloudStack doesn't support it. So we should disable most of the features to only use its firewall service and spoof guard. So this is you know, the UI of the vCenter, and by clicking on the network and security, if you install the NSX, you can see this option here. You see this window here. You can see that we don't install NSX node controller node because we don't need it. I told you that the features that we need to be available is only firewall and a spoof guard. So we don't need to install controller nodes. Then we should configure. You can see firewall is enabled and VXLAN is disabled here. We enable firewall, disable VXLAN, or even we don't install VXLAN at all. And then we change IP detection type here. We check that we use DHCP snooping and ARP snooping. NSX uses these two methods to detect the IP address, the actual IP address of the VMs. So we use it. No. To prevent DHCP snooping, I should show you some the way that DHCP works and the way that DHCP protocol works. In DHCP protocol, we have 4 types of message that is between client and servers. When a client want to get an IP from DHCP server, it send a DHCP discover message to the server with source of 0 from 68 port of UDP to the destination of broadcast. You can see the MAC address and the IP address are all broadcast type. To the destination of 67 UDP. Then server gets the request from the client and answer it to destination of the selected IP. Server will select the IP to the client of MAC address of the client, and then the client will respond with DHCP request to it, and then DHCP ACK. Something that is important in this diagram is that if we want to prevent, to control the DHCP snooping here is to prevent servers that are not allowed to answer DHCP discover and DHCP request and sending DHCP offer and DHCP ACK to we should deny them to send packet with this scheme. It means that they don't. We should block packets with destination address of destination UDP port of 68, but not for all the DHCP servers. And also we can limit the clients to send their request, but in this case it is enough. If we prevent server from sending their packets to the clients, we can say that we have prevented the DHCP snooping, DHCP spoofing attack. For this reason, in NSX, we should create some kind of security groups. Security groups is a concept that you can create some entities by their different features, so you can use it in security policies to define some security rules for them in firewall. For example, we want here we want to detect our routers, virtual routers in CloudStack. You know, virtual routers in CloudStack. We can click at here to create a security group here. We call it VRVM. Then we tell this security group model that we want to create membership based on the VM name. If every VM name match with this regex, then consider that VM as a member of this security group. You know, the virtual routers in VMware that is created by CloudStack use this type of regex for its name, R dash some numbers dash VM at the end. So with this scheme, we can detect virtual routers, actual virtual routers, and create a security group for them. In the continue, we don't need to do anything here and even here. And then we click finish. As you can see, automatically NSX detects all virtual routers, and you can see 26 virtual router is detected here. So now we have a security group for virtual routers. In the next tab, we create a security policy to allow virtual routers to communicate on DHCP protocol. For this reason, we click on Add, allow DHCP servers. We write some name and description here and leave the rest. Here is not, we don't need to do anything. Here in firewall rules, we should add some firewall rules. We click on Add, and then we select the service that we want to provide to customer. This DHCP client, it means that when you want to accept traffics to this is destination, to this service, it means this is 68 UDP port. So you can see that this is we tell that if we traffic originated from security group that we have created before to any destination to the services that we have defined, that is the DHCP client, this rule will allow it. Okay, so in this rule we tell that virtual routers can send the response to any servers, and we allow it. We also create the vice versa rule for DHCP server. It means that we allow all servers to answer DHCP, to send requests to DHCP servers on DHCP server port 67 port UDP. This is the firewall rule that we can use for allowing VMs, and the rest we don't know. We don't need to do anything. Okay, this is our rule. Now we should apply this rule to the security group. When we select apply, we can select the security group we need. Then when we apply it, you can see in the firewall section, you see that the virtual routers can send traffic to any VM on DHCP client port, and any VM can send traffic to virtual routers in DHCP server. So they are. This is allowed here. At the continuation, we should also allow clients to send broadcast message to this address to DHCP servers. Otherwise, it doesn't work because NSX translate these rules to IP addresses. So if we want to limit the clients to send the DHCP request, we should allow it explicitly to this broadcast address. This is, we should explicitly allow it to broadcast, client can broadcast to DHCP server. And then after that, we should block all the DHCP traffics in our infrastructure. In this way, the traffic will be only allowed with the DHCP server that is defined by CloudStack and the other VMs. So other VMs cannot create some DHCP server on our infrastructure. The other concern is about the spoof guard and about IP spoofing. We want to allow only VMs to use the IP that is provided by CloudStack to them, and and prevent them from using IP addresses that is not registered in CloudStack. Spoof guard can detect IP usage by ARP and DHCP traffic and block packets from VM that their IP is not approved in CloudStack. And also it detects IP conflicts, so it should be helpful for us. In this part, I want to show you how to configure a spoof guard for CloudStack. Here, this is default policy and this is disabled. We should create a new policy here. You can see the detection type here is ARP and DHCP. We click on add, and then we name our policy, for example, protected. We create it, enable, and the mode is automatically tell us IP assignment on the first use. It is necessary for CloudStack because CloudStack need to communicate with DHCP server for example, get password for its initial stage. So if we select it to manually inspect and approve all IP assignment, then CloudStack VMs cannot get password exactly after they are after powering on. So we should trust the IP at the first use. Then we should select networks that we want to this policy apply to. For example, we select two of networks that is or shared networks, shared public networks. So we add it to this policy and then click on finish. And then you can see this policy is shown here. It detects 3 IP conflicts and need 2 approvals. If we go to approval page, you can see that CloudStack detected these IPs on the VM, and these IPs are approved, but this IP is in pending approval. This is detected, this is approved IPs, and this is pending IPs. Here you can see there is a pending IP that is it's not in this range of IP, but this range is, these are detected IPs and these are approved IPs. If an IP is not approved, obviously client cannot send or receive packet on this IP. In the section of duplicated IP conflicts, you can see there is some IP conflicts here. For example, in the detected IP, you can see 3 VM are claiming just 1 IP, okay? But approved IP here, only these 2. And pending IP here, these IP. You can see it is clearly that obvious that this VM is the VM that is its approved IP and detected IP are the same. But these 2 VM try to steal this IP address, but SpoofGuard prevent these 2 VM to steal the IP. But all of this operation should be done automatically with help of API of CloudStack and NSX API. So I have written a Python script for that uses CloudStack API and NSX API to automate this procedure. So you can, if you have the same infrastructure, you can use it. Let me open it. I don't know how much time do we have. Okay, since we have 10 minutes.
I think we're okay in terms of time, so yeah, you can continue.
Thank you very much. I have written an script here that I use it to do this operation automatically. Here is some information about how to install it and its configuration file. You need to provide some credential about NSX and CloudStack to it. And it will query, it will make a query on NSX about, let me show you. It will make a query to NSX and get all of these items from NSX, and these items even, based on the nature of these items. And decided and get the related item from CloudStack and decide what that is, this detected IPs or this pending approval IPs are allowed to being approved or not. If it is allowed to being approved, it will approve it. It's not, it will not approve. But for example, in this case, you can see that this, if you don't approve it, in the next iteration, you will see it again, and it will send requests to CloudStack over and over. So for this part, I have designed a very simple caching mechanism that can detect that it has decided about this item before, so it won't send API call to CloudStack about this item or this item if it has some decision about them before. So it is efficient in this point of view. If it detects a new item in the pending approval IPs or duplicated IPs, it will take an act about it. So it will call CloudStack and get a list of all approved IPs on that MAC address. It will get the MAC address of the VM from this item, and then compare it with the MAC address in the CloudStack, and then get the exact IP address of that interface, and approve only IPs that are allowed to be used by that VM. So the mechanism of working of this script is by pooling. So we should add a cron job for it and run it, for example, every 1 minute. So we can, in this way, we can manage new IPs that is assigned to the VMs, and in this way we can have an automated and loosely integrated NSX spoof guard to our CloudStack. That's all. If you have any question about it, I'm at your service. Let me show the presentation. Okay, if you want to use this QR for yourself. Okay.
Thank you very much, Alireza. We will be happy to share also the slides and the QR code and everything with our event participants after the event. Now I'm going to the Q&A because I see we have quite a lot of questions. So first one is coming from Suresh, and he's asking, any possibility to perform the NSX operations, specify, control the policies, rules from CloudStack through a plugin?
I don't get exactly what he's mean, but he may say maybe we can automate it. This script is not automate this section that we can add the networks from VMware based on their names or their other properties to the policies that we have defined in a spoof guard. So we can extend it, but I didn't do it here. It is a to-do work. If anyone can help, we can add it to this.
Yeah, it will be very nice if you can also find some other people who can help you on this and on this contribution on the CloudStack. I'm pretty sure that if somebody is interested, you can engage after the conference, or you can maybe connect on the mailing list.
Yes.
Going to the next question. Why did you choose a paid for platform NSX? Did you consider any other open source SDN platforms such as Tungsten?
Such as?
Tungsten Fabric.
If you see, this platform is a little old platform. You know, NSXV is older than NSXT. That is new in this industry, and we had this before in our company. So we try to use as much as we can from the assets that we have in the company. But I didn't work with Tungsten about this feature. I don't know, it is possible with that product or not, but if it is possible, it's very good to integrate it, because I think it is a very valid concern about sharing common infrastructure between VMs.
And which version of NSX is supported in your use case?
I think from a slide, I can show you the version of NSX that we have installed. Maybe the first slide. Let me close it. I see somewhere about the versions. I don't know, but it is NSX-V, not NSX-T. I don't know the compatibility between the APIs, but the concept of written code is the same. So if anyone need to have some change on it, it is okay. You can use some. You can use new NSX API if it is applicable. About no, I don't have it. I can tell you later. It's a very good question. I should take into it.
No problem at all. And one last question, isn't it not very cloudy having to approve IPs?
What, please?
Yeah, the question is coming from Alexander Mattioli. Isn't it not very cloudy having to approve IPs? So maybe he's asking whether it's too complex to approve IPs or if you have some difficulties.
You know, approving IPs is in such. I can say that CloudStack or even VMware don't have any native solution to restrict the VMs to their exact IP addresses. So it can make some security security vulnerabilities to our infrastructure, and even when you consider that you are a client and you are happy with your VM, and suddenly someone comes and steal your IP address, and you see that you see the error in your system that you have an IP conflict. So it is the task of the cloud provider to prevent such issues and don't let others to use your IP address. I don't talk about some security or some regulation, and some security or issues that it can create for you. For example, this IP is registered on your name under your account, but somebody use it for example, hack somewhere or have some attack on somewhere, and you are responsible because in the systems you are the one who have this IP address. So we should prevent this kind of issues.
Yeah, thank you. Appreciate your detailed answer. I think we don't have any questions so far. Maybe just one final question for me. I see you are in the CloudStack community for a long time. How did you actually choose to use CloudStack, and what are the benefits it brings to you?
I'm using CloudStack, or maybe playing with CloudStack, not exactly using, from its early versions. I think it is 4.3. That was 4.3 or 4.4, as I can remember. When some of my friends introduced CloudStack to me as a cloud service, as a cloud provider, as a solution to provide some cloud services to customers. So at that time, I'm looking to this project, and when I joined to Afranet in Iran, I introduced this solution to them. So they welcome it, and I can say it is a very monolithic approach to manage cloud services, and we can manage a very good, a little great system of cloud service by a few number of engineers. It is not very possible with OpenStack, for example, and the complexity of the system in OpenStack is very more than CloudStack. So I think the cost of operation in CloudStack is very low. It is ready to market. It is you can see that it has a backend from the market to the open source, not from open source to the market. You know, it was a paid solution. You should pay for the cloud.com license, and then it goes to the Citrix and then donated to the Apache Foundation. So you can see there is some backend from market to it. So I think it is very good for companies that are that only wants cloud infrastructure as a service and don't want to be very overloaded by some bugs and issues to management of the cloud.
This sounds like a really good reason. Thank you very much once again, Alireza, for having you today as our speaker.
You're welcome. I'm very glad to see you, and I hope you have a good time.
Thank you. And as I already have notified all of the participants in the platform, unfortunately, we have an unexpected issue with our next speaker. So he will not be able to join us, and we will continue exactly at 3 p.m. Central European Time with the next talk from Vidu de Huandar. I'm pretty sure it's one of the most expected talks for the day. Thank you, everybody, and enjoy the short break.
Thank you. Bye.